validTime. So I guess we might as well do that. All right, so task 53, validTime, it's basically giving us a string, and we want to know, is it a valid time? Is it a correct representation of a 24-hour clock time? Okay, so, I mean, if you're not familiar, if you've never encountered like a digital clock or something like that, basically the idea is, in particular, since this is a 24-hour clock, these numbers over here can only go from 0 to 23, whereas these numbers over here will only go from 0 to 59. That's the idea. Okay, so basically, if we wanted to check this, we could sort of go through it like one character at a time in the same style as we've done in some of the previous ones. But I think what we'll do is we're going to take advantage of a built-in that we've got available to us. It's one we've used before, but we're going to use it in kind of a different way this time. So it's dotsplit. So just before we go any further, this is sort of the way we've normally used dotsplit. This is how we've used it in the past. And it's basically just a way of taking a string and converting it into an array containing every character of that string. That's not really what we want here. What we want is for it to be splitting basically right at this point here. We want the stuff that's to the left of the colon and the stuff that's to the right of it as well. Okay, so for that reason, we're going to use the colon as our splitting character. We're going to run that, and basically what we get, it will be an array containing, well, hopefully 2 elements. Yeah, so we get the 25 and the 51 over there. I mean, there may be some test cases where there's like more than one colon, in which case that's going to be no good. So let's see. All right. Basically, the idea here is, well, there are a couple of things. So first of all, we want to have 2 parts here. If we have more than 2 parts, then that's pretty much no good. So, or even if we have less than 2 parts. So we could say something like, actually here, let's split this up. Let's say let parts be assigned the value of this thing over here. Okay, so that's parts. And then basically what we're going to do with that is we'll say if parts.length is not 2, well then we're going to return false. There's no way it could possibly be a valid time if that's the case. Okay, so basically from here, we know that there are going to be 2 parts. If we make it past that if statement, there has to be exactly 2 parts. So we'll say let hour be assigned the value of parts at 0, and let min be assigned the value of parts at 1. And I guess we probably, well, okay, let's not go any further for now. Let's just say basically what we want to return is this. We'll say the hour has got to be somewhere between 0 and strictly less than 24. Almost forgot JavaScript can't do double inequalities like that, so there we go. And what else needs to be true? Well, the minute also needs to be no less than 0, and it has to be strictly less than 60. So it can be 59, it just can't be 60. So let's try running that and we'll see if that works. Well, hey, that's pretty nice. It's passing all the visible tests anyway. Let's try submitting it. We'll see if it passes the hidden test as well. And okay, I'm actually a little bit surprised at that one. I thought that we might need to actually convert these into integers. I was expecting to have to do like a parse int on this thing, but I guess the lexicographic sort is working for us here. So, okay, before we go any further, I just want to make it clear why we need this line here. Well, actually, hey, let's check if we do need that line there. Maybe we don't. Oh. Okay, well, I do have to say, I would have preferred maybe more test cases here, because if we had something like this where we said time is assigned the value of, maybe it's like 23, 59, 59, or 57, just to make them a little bit different. But the point is, that would be a time. We're going to get parts. Oh, actually, good point. That wouldn't be a problem, because here, let me do this. So So if we return parts here, this one actually wouldn't be that much of an issue just because like it's got this extra bit here. Well, okay, well, sorry, I keep changing my mind. I must sound very fickle right now. The point is we've got 23, 59, and 57. The point is, like this would still be considered the hours. This would be considered the minutes. Notice that we do have 3 parts because there are 2 colon characters here. And if we're splitting at those characters, then basically there's the stuff before the first one, there's the stuff between the second and first and second one, and there's the stuff after the second one. Okay, and then basically for the parts that we actually get here, these are being represented as strings. It turned out not to be a problem here. It probably wouldn't hurt to convert these into integers, but anyway, the point is, so we have 3 things here, but really the ones we care about are the first 2. So the thing is, this one, it should still, well, this actually would still give us true because the hour and the minute are still appropriate. They're within the range that we're looking for here. We have this extra part, which would be like parts at 2. But that's not really causing a problem. So that's kind of bad. Like that's the reason we want to put this thing in here, because otherwise, let's get rid of that return parts and let's run that. So basically the idea is that, yeah, we're getting true, whereas this thing, it shouldn't be true because it's not a valid, like, it's not what we would expect for a representation of a 24-hour clock where we've got too much information. And even, you know, we could put like some extra stuff at the end there and we would still get true because it's only looking at the hours and the minutes. Okay, so this is actually bringing us to a really interesting point. We would normally want to include this line right here because this is the thing that would actually cause this to become false, because it's saying, oh, well, yeah, I know the first 2 check out, but there's too much stuff there. You know, you've got extra bits and we don't want those. So you might look at this and think, well, hey, okay, I see why this line is here. I understand the principle behind this line, but as it turned out before, if we were to get rid of it, it's still passing all the tests. So we might think, well, do we really need this then? I guess we don't need to include that. This is kind of, there's a broader point here that I'm trying to make, and it's this. We talk sometimes about like what good code is, right? Good code is like good time complexity, good space complexity, human readable, all that kind of stuff. The main thing, and this is a point that I don't want to like underemphasize here. The point is that good code is honest. Good code solves the problem. Good code doesn't take advantage of some kind of loophole. It doesn't exploit poor test coverage. You know, there are only 8 tests here. Really, there should be more. There should be one like the one that I had above, which, you know, would pass even if we didn't have this here. But you know, it would be nice to have more tests like that. But the point is, we're not always going to get all those tests. So we shouldn't be trying to just build a code that passes the tests that we have available, even the hidden tests. We should write something that honestly solves the problem, something that does what it should do. Because look, if you're making an app or something like that, yeah, you might have a few test cases that you've thought of, but there's going to be a whole bunch of edge cases that you'll never think of, right? So you want to try to address as many of those as possible. So basically the idea is that good code is honest. It solves the problem. We're not cutting corners. We're not doing loopholes and stuff like that. We're getting the problem done. Okay. So I think I'm going to leave this in here because it's more robust that way. But we're gonna clear this. We're gonna archive this. We're gonna wrap it up. Okay, and now we're gonna get something new in here. We're gonna try this a little bit differently, because the thing is, we're given a string representation of this, right? It's gonna be a string. So because it's a string, that means, well, maybe regular expressions, right? Maybe that's what we want. So regular expressions. Basically, we could do something like this. Return, we'll do a regular expression in here. .test with our time. Okay, and what do we want it to look like? Well, basically, we want it to be, well, okay, we want it to be some digit, times 2 actually, 2 digits, and then a colon, and then 2 more digits. That's basically what we want. And in fact, well, okay, first let's run this. let's see what's happening. So it's saying that this is true because it's 2 digits, 2 digits. We'll look at that one in just a sec. This one, it's also saying is true, which should be false because 76 makes sense. 24, yeah, okay. So I was really hoping for a bit of a different example here. Let's say time is 345.99. There. Okay, so obviously that should return false because it's not just 2 digits, but look at that, we're still getting true. So the reason is because it's basically just taking a look at this part in here and saying 2 digits, colon, 2 digits, it works. So we need to specifically say, we've got the start of the string, then we've got 2 digits, then we've got a colon, then we've got 2 digits, and then we have the end of the string. So now if we run this, we'll get a false on this thing. Okay, nice. All right, so let's get rid of that. A regular expression is coming along, but the thing is, as we saw before, it's not really paying much attention to what kinds of numbers we have in here. It doesn't really care. It's like, oh yeah, whatever you want, right? So we're gonna have to think a little harder about this. It's not gonna be quite as simple as just accepting anything here, right? So basically, for the first part of this, we could have something like, I guess let's just put this in parentheses for now. It's not actually necessarily going to be like a capture group, but we'll put it in there. The main thing is that we're going to have, okay, basically this thing could be, we could have, we want to go through all of our options here. We could have, yeah, 0 and then any character or any digit, so like a 0 and then a digit. Okay, or we could have a 1 and then any digit. Okay, or we could have a 2 and then just anything from 0 to 3, I guess. Yeah. So let's try running that. We'll see if that cuts down on any of this. Oh no, what did I do wrong here? Did I like put the wrong parentheses or something? Here, let's work on this. Oh, I've got a backslash. Okay, maybe that's the issue. Yeah, okay, that's better. So that works. This one, great. It's saying false. This is not within the range we're looking for. This one is telling us true because we're not yet checking out that part. And then this part over here, that's telling us, ooh, it's telling us false. It should be false, yeah, because it couldn't be 24. It's got to be strictly less than 24, so like up to 23. Okay, great. So good, very good. All right. So now let's look at this other part over here. We had 2 digits. Now instead of 2 digits, what we want is okay. So it could be, I guess the first digit could be any number between 0 and 5, right? Yeah, first digit can go from 0 to 5. The second digit, it could be anything, I think. So that's just going to be /d. Is that it? Is that the only possibility here? Yeah, that might be the only possibility. Let's try running that. Is that going to work? Okay, so that passes the visible test. Let's try submitting that. Okay, cool. So I guess I don't really need the parentheses around this one. I'm pretty sure I do need them around this one because I have these little or statements in there. But let's just, how do we do this again? I think it's like this to make it a non-capturing group. So let's run that on the visible tests. We'll see if that's passing those. Yeah, good. So let's try submitting it and hopefully, yeah, okay. So that's passing the hidden test too. Cool. All right, well, that's pretty neat. That's a bit better. I mean, I always like to use a regular expression if we can. You can see how much time and effort it saves us, how many lines of code we economize by just using this, well, let's be real, this very confusing looking statement. So just to sort of break it down here, we've got the 2 parts. This over here would be the part before the colon. So this is like the hours component. And then this over here is the minutes. And we found the minutes actually pretty simple. It's just any digit between 0 and 5 within that inclusive range. and then just any digit after that. We didn't really need to restrict ourselves as much as we did over here, because in this case, actually, you know what? I just realized something. We could just say it's 0 or 1 followed by a digit instead of having to worry about that or thing. So this can get, yeah, a little more efficient. So if the first digit is a 0 or 1, then the second digit can be anything. If the first digit is a 4, then we can only have 0, 1, 2, or 3 as the next digit after that. So if we run the test on this, I think that should still work. Okay, and by the way, you might be looking at this and thinking like, well, why didn't you put 0, 2, 1? Why just 0, 1? Well, keep in mind, anything in the square brackets like this, these are just options. So it could be 0, 1, 2, 3, something like that. Like this is the equivalent of saying 0 to 3. So if it's 0 to 1, well, that's just 0 and 1. So it's probably fine like that. Okay, so that's nice. Now, there is another thing I wanted to mention here. There's another tool that we can be using in case you're faced with a situation like this. And it's this. Okay, so regular expression numeric range generator. So if we wanted something to go from, I guess it's 0 to 23 is what we're looking for. So generate the regular expression. There we go. That's what it's going to give us. So we could use that, maybe copy this part here and then do also 0 to 59 and generate that. And then we could put that in here. Let's do that for the sake of comparison. So return start of the string, first thing, and then end of the string dot test. What was it? Time. And now we'll paste in that other part. So there we go. That's our 0 to 59. We'll put that in over there. And what we'll find is that it's still going to pass the test, but this one's like quite a bit nicer, I would say. Yeah, let's take a look at this. So, okay, that's the other thing. This one isn't considering the leading 0 on this thing. So like the 0, 2 here. So maybe that's worth considering. Yeah, I kind of like this better down here. So, I mean, I guess all that to say, like this, it's a very cool, nice tool that you can use. It could help us out, but I don't know. I mean, I think probably generating it yourself, creating it yourself is, I would say, the better way to go, because I'm more happy with this result than the one up here. Okay, so I think that's just about all I have to say about this one. So let's just submit that. And yeah, there we go. Okay, so not too complicated, this one. I mean, we're really just checking to see if this is a valid time, and yeah, that's it. Okay, so yeah, cool. Let's finish up with that one. Nice.